For this project, we were to design and make two prototypes that would allow us to minimize the force of a collision and prevent the block from falling. For this project, there are several variables that are being put into play. First, there are the independent variables, which include the maximum height of 30 centimeters of the ramp, the height of the the mass of the airbag system, and the total kinetic energy. For the dependent variables, there are the remaining kinetic energy after the collision, the resulting force, and the block's stability. Prototype, we created it using cardboard, bubble wrap, and duct tape. This prototype was made by using bubble wrap and cotton balls to make a cushion, with the cardboard box acting as a shock absorbent and a wall to prevent air resistance on the block. We hypothesized that with this airbag, it will allow for the cube to remain in place by having the bubble wrap act as a cushion to decrease the amount of kinetic energy transformed from the time the cart was released to when it will hit the pressure. We have designed a process. To start the testing of our first prototype, we, after making it, placed it at the top of the ramp, and while still holding it, asked either another team or classmate to hold up the pressure plate. While doing this, a third person will take out their laptop and connect it to the pressure plate to record the force caused by the new car airbag system. Then, when each person is finished setting up, a fourth person will take their phone to record the trial. To do this, they will start recording and will call for the other member to complete their task. The person holding up the pressure plate keeps it up, the person holding the cart let goes, the person at the computer clicks so that Logger Pro begins recording the force, and finally the person recording gets the whole trial. Once this is complete, the force data will be analyzed and uploaded to the write-up. Then, the video that was just recorded will be placed into Logger Pro to find the velocity graph and acceleration graph. Both will include the regression equations. After this is complete, they will move on to the next trial with the next prototype, and the process will be repeated. In this next clip, we are carrying out our trials for this prototype. From these clips, we gathered our qualitative data, as we can see that when sliding down the ramp, the block and airbag were shown to be quite secure and lacked any indication of instability. However, when the car airbag system made contact with the pressure plate, the block flipped over. The speed of the cart seemed to be consistent with the other trials, and in accordance can be assumed to be a fair assessment of the airbag's effectiveness. After completing the trials, we collected the data from the pressure plate and the data from the videos using Logger Pro. This is our quantitative data. In this force time graph, we can see how the cart exerted a force of about 9.8 newtons, which was 25.1 newtons less than the original force exerted. Once we completed this process, we moved to the second prototype, which used different material. This prototype used cotton balls, paper, and masking tape. This prototype saw a different approach from the first prototype. This one was made by using a large sheet of paper which was cut into strips of similar lengths. Then 4 to 5 of these strips were taken, folded in half, and made into a zigzag shape to act as a spring. The remaining paper was taken and then folded in half and connected at their ends so that they could encapsulate the cotton balls and paper string. These were then taken and taped to a cart. We hypothesized that this airbag will keep the block upright by having the paper spring act against the pressure plate to reduce the amount of force that would act immediately on the cart block system. It would do this by pushing the cart back, which would allow the energy to decay. Additionally, the airbag will be able to achieve its functional requirements by having the cotton balls act as an additional cushion for the block. Then, to test this prototype, we used the exact same process as the one stated before and the same independent and dependent variables. In the following video, we demonstrate the effectiveness of this new prototype. Again, we were able to observe our qualitative data from the videos. So while the prototype reduced the impact force, it wasn't able to prevent the block from falling over. In addition, the speed of the cart is consistent with previous trials and the airbag was secured tightly to the cart, so it did follow all the functional requirements. Using the video recordings we found using Logger Pro, the velocity and acceleration of the cart. As for the force graph, this was found by using the pressure plate during the experiment. For our force graph, we found the maximum force caused by this airbag to be 10 newtons, which was 24.9 newtons less than the original force caused solely by the cart. When building these prototypes, we did run into some difficulties. So in making the prototypes itself, the cotton balls would tend to prevent the tape from being reused and they would ruin the adhesion of the tape. And for some of the prototypes, some of them would be far too large and as a result would have to be taped up to prevent any friction. Lastly, an issue that would pop up frequently was when the airbags were quite difficult to tape up in general, whether that be due to their size or what they were made of. Additionally, friction would often be a major role in not allowing the cart to travel down the ramp smoothly. Regarding testing itself, when using cotton balls, we found that cotton balls would prevent any adhesion for the tape it was attached to and made it very hard for us to stick things to the cart itself. Another problem that arose was that it took numerous attempts to find a prototype itself that could work, and many of the prototypes made would cause the cube to flip over even with large amounts of cushioning. If we were to make another prototype, this one would have been used making shapes such as cones to our advantage. We would have made a cone-shaped airbag that lacked any internal contents that would prevent compression. This compression would have reduced the kinetic energy of the cart block system, which would have allowed for a softer impact, therefore reducing the force and not allowing the cube to tip over. Despite numerous builds and trials, we were unable to make a prototype that would prevent the cube from flipping over. However, from these attempts, we were able to develop a better understanding on how to make an effective airbag as the project progressed, even if we didn't get the result we were looking for in the end.